Okay, so this week we're going to be talking about circles and arcs, which are portions of circles, but very specifically portions of the circumference of the circle. And we'll be dealing with other parts as well. In fact, we're going to be talking about what a circle is here and some features of it. And you may know this, I think I've said this in class. In a plane, a circle is the set of all points that are equidistant from a given point we're going to call the center, okay? And it's interesting to note what they're saying there, okay? A circle is not a solid thing. It is a set of individual points. There's an infinite number of them, but that's what a circle is. You essentially, if you look down here in the diagram, or actually look down here on the very bottom, here's your center, your P right here. And if I just said, I'm allowed to go, notice that it says in a plane, so I have to stay flat, okay? Um, we would get a sphere if we didn't stay on a plane. But if we're on a plane and I say, okay, I want to go, let's say, a centimeter from here. And I want to go a centimeter from here in a different direction. So I land in a different spot. Centimeter, 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 centimeter. And you just kept doing that all the way around, infinite number of times, each at a new location, all equally distant, whatever the radius is, from that center, and you'll form a circle. In fact, that's a good, easy way for you to make a circle is, and you see a compass, right? You put the point right in the center, and then you swoop the arc around, and you would set it at a particular radius, and so it just makes an infinite series of points, all equidistant from the center. Okay. Now, here's circle P, okay, and there's just the point at the center. A diameter, then, is a segment that contains the center of the circle and both endpoints. It essentially runs from one side to the other side through the center. Okay, that's a diameter. And a radius is one half of that, starting at the center and going to the end point on the circle. Okay? So a diameter is just double the length of the radius, and you're going to need that. Some of this you might know. Congruent circles have congruent radii. If you have congruent circles, that means they are formed by doing the exact same thing from a center going the same distance. Otherwise, they wouldn't be congruent, right? Just similar. So if they're congruent, you know the radius is the same, and if the radius is the same, that's what it says here. Okay. And a central angle then is an angle where the vertex is the center. So you go from the edge of the circle to the center, and then to another spot on the edge of the circle, and that will then be a central angle because it's going to the center. Yeah? Okay? So here, APC, notice that they're naming the angle as one endpoint, the vertex and the other endpoint, just like we do with angles, 3 letters, right? Because there's more than one angle coming off of here. And AB is a diameter because it goes straight from one side to the other through the center. PC is a radius. Okay, now you can find the length of a part of a circle's circumference by relating it to an angle in the circle. So I'm going to just sum it up real quick here over on the side, give you a preview of what you're about to do, which is if you say that there's an angle that is 90 degrees and the entire circle is 360 degrees, then you simplify that to 1/4. You want 1/4. You're talking about 1/4 of the circle. And if you're trying to find the circumference of some portion of that, the 1/4 of that, you would take the circumference of the circle, which the formula is the circumference equals pi times the diameter. Otherwise, the diameter is otherwise known as pi times twice the radius. Okay, pi times 2r or 2 pi r. And then you would just take 1/4 of that, and you would know because 90 degrees is 1/4 of 360, so you're going to take 1/4 of the entire length around the circle. Okay? That's what you'll be doing as part of your work. Now, an arc is a part of a circle. One type of arc is a semicircle. Semicircle. It goes from one side of a diameter to another. Okay, half of a circle, right? Exactly half a circle. It's got half the area. It's going to have half the circumference, half of the angles, 180 degrees. Okay. Now, a minor arc is smaller than a semicircle. If you were going from, let's say, here R to here S, you're going less than 180 degrees, right? So that's a minor arc. Now you could go from that same point all the way around the long way like that, and you have a major arc. STR is a major arc, and they have to, notice what it says, the major arc is larger than a semicircle, and you name a minor arc by just its two endpoints, RS, and a major arc by its endpoints, which are also RS, but also another point that shows that you're going the long way. You have to go from S to R through T. Okay, and that makes us know that that's a major arc. Yep, okay, those are all the details. And we'll use them in just a second. Okay, sum it up. Center of a circle, all distances from that center to the edge are called radii, and if you go from one side to the other through the center, that's the diameter, okay? Congruent circles have congruent radii, they're the same size, and a central angle is this angle that's formed from going from the circle to the vertex at the center and then to the other edge here, okay? And semicircles are half circles going through the center, one diameter through the center, 180 degrees. Minor arc, the short way from one point to another on the circle, less than a semicircle, less than 180, and a major arc goes the long way around and is more than 180 degrees. That's all of it. Let's keep going. Right. So here's the first part. You're going to just name arcs. What is the minor arc? What are the minor arcs of circle O? Minor arcs are anything that doesn't go all the way, halfway around or more. So if you see a diameter like this, you're not going to go from D to C because that's a semicircle. You're not going to go from A to E, that's a semicircle, right? And you have to go the short way. So if we go from A, the short way to D, we got AD. If we went the short way to C, we get AC. We can't go all the way around to E either direction because that's a semicircle. So now we move to another point. We already did AD. Did we do DE? Nope, DE is right there. Okay. DA and AD are the same. We already named that. Let's go to this point. We already named ED as DE, but we didn't do EC, also known as CE. That's right there. Those are all the four minor arcs. Here, 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 and here. And if there are more than two within a semicircle, you could actually add them together. You'll see that in a minute. And get more of them. But right now we're only dealing with this. So what is the semicircle of circle O, or the semicircles? Well, we got to go from one side to the other, A to E, but we've got to say what we're going through. So ADE, that's this right here, A to D to E, right? Going from here to here, or we could go A to C to E that way and talk about that section of it. That's a straight line. We can assume a 180, remember? A to C to E, that's right there. So that's going here to here or here to here. What if we went from here to here? DAC, it's right there, or DEC, DEC. Notice how the only thing that we need is that we have to have the endpoints at the ends and the point that we go through in the middle. So I called it CED, but I could have also called it DEC. Yep, semicircles, okay, half circles. Now, what are the major arcs? Now we got to go a long way around. So let's start from each point. Let's start here at A, and let's go through C and E to D. ACD or AED? ACD. We don't write also AED. ACD and AED are the same section of circle, right? You just name one of those 2 points. So we could have also called that AED. They called it ACD instead. Okay. Now let's go to another point. C through E to A. Or it could have been C to D to A, but they called it C to E to A, right? That's starting at A, then we went to start it at C. Now let's start at E. We can go E to D to C, which they did, or E to A to C. Either way is fine, okay? And what about moving to D? D to A to E, or also known as D to C to E. Whatever, you just need to name one of the 2 points that it runs through in the long ways, okay? Now, what we shouldn't have is major arcs that go notice that we started here and went in this direction always. If we said A, C, D, and D, E, A, those are describing the same part of the circle. And so you don't want to do A to C to D and then go backwards from D and have the same endpoint going in the same direction. Okay, so notice that these don't have the same endpoint. This is A to D, like that, the long way. This is C to A, the long way. This is E to C, the long way, and this is D to E, the long way. They all have two different endpoints. Okay. Yep. Here's your got it problem. Okay, what are the minor arcs, what are the semicircles, and what are the major arcs? And you want to name them all. So you're going to pause it, you're going to try and get them all, not just some of them. Okay, so pause the video now, write your answers, and then unpause it and check it. Pause it now. Okay, what are the minor arcs of circle A? And notice what they do, just like a segment, they put the letters on. I'm going to write here for A. I'm going to make a list of them. I'm going to say SP, and notice I'm putting an arc like that on top. That's how you describe that as a semicircle arc or whatever, okay? Yep. Okay. What else do we got? That's going from, and I'll just mark them off. That's going from here to here. Could I keep going and still be less than 180 degrees? Yeah, I could go from S to Q. So I'm going to say SQ is also 1, okay? If I kept going from there, I would go past 180 degrees, and I'm only doing minor arcs right now. I can also go this way, and that would mean that I've covered everything that's got S as an endpoint. Okay, so SR, sure, why not? Okay, what else can I do? Let me erase this. Okay, let's go to P. Let's go to P. P to Q, sure, we can do it. I'm going to write it. Remember, you have to have unique endpoints, or it's not going to work. All right, you'd be repeating them then. Okay, so we did P to Q. Can we do P to R? No, that's a semicircle. Okay. Can we do P to S? We could, but we've already got SP right there. So we're not going to go that way and do something we already repeat the endpoints. Can we go this way? No, that's also a semicircle. So we've done with P. Now let's go to Q. Q to P, we just did that with PQ. Q to R, sure. We can do Q to R. Okay. What else can we do from Q? Q to S, no, that's too far. Q to S that way. Nope, we got Q to S right there. So we named them all. Okay, that was A. Now let's do B. What are the semicircles? Well, we've just got to look for diameters, and we got to go in both directions for the diameters. So this is the one diameter that we've got. So we're going to go R to S to P and R to Q to P. Going in one direction. Every semicircle is going to have its match going in the other direction. Same endpoints, different direction, right? Sorry. R to S to P, and then R to Q to P. And we'd have more than those two if we had more than one diameter, but we don't. We only have the one diameter, so that's the only two that are going to be made. Okay, what are the major arcs? Well, now we've got to go the long way around. So can we start at S? Let's say we start at S here, and we go, going from to P to Q is not far enough. We've got to go at least 180 degrees, so let's go S to R, but we've got to name one of these points. You can say SPR or SQR. SPR, and I'm going to put it, or SQR, because those are the same, going from S to R the long way with just naming a point in between. Okay, let's keep going. Can we go from P anywhere? We can go from P to Q, no, that's a minor arc. P to R, that's a semicircle. P to S, sure. Did we get P to S? No, we didn't do those endpoints P and S, so we can say P running through Q to S, or P running through R to S. Both ways of naming that. Okay, now let's go to R and see what we can do. Right here from R. Can we go to S? No, that's a minor arc. P, no, that is a semicircle. To Q, we could do that, but RQ is, oh, no, we didn't do RQ yet. So let's do that as endpoints. R, and let's see, R SQ or RPQ. Both of those work for names. Or RPQ. And I hope that you realize that I'm right here just naming the exact same arc two possible different ways by having a different point that they're running through, picking a different point that they go through the long way. Okay? We tried S, we tried P, we tried R. Let's try going to Q. Going from Q. Q to R, no, to Q to S. Yeah, did we have Q to S yet? Nope, we did not have Q to S as endpoints. Could we do Q to P? Let's see, we didn't do Q to P either. So we can go Q to S, Q to P. Okay, let's see. QRS, or, nope, that's the only way to name that one because there's no other point that it goes through there. Okay, what about if we kept going though? We could say Q to R to P, otherwise known as Q to S to P. Okay, and notice, just to be sure of what I'm doing, when I look, I say, here we've got endpoints of SR, and none of the other ones have endpoints of SR. Okay, here we have endpoints of SP, none of the other ones have endpoints of SP. Here we've got RQ as endpoints, none of the other ones have RQ as endpoints. This one has QS, none of the other ones have QS as endpoints. And QP, none of the other ones have QP as endpoints. So I didn't repeat anything by having the same endpoints and just accidentally name it. I mean, I named them different ways just to show you. Okay? Sorry that was long, but I hope you get that. Okay, sorry, we got a little erase, something got erased there, but you can read it. So, what do we got? What does arc measure mean? Well, the arc measure is of a minor arc is equal to the measure of its corresponding central angle. So since from R to T is the minor arc of that, instead of not going around the long way, then if this central angle is 50, then that's what we call this, okay? So the measure of R to T is the measure of R to S to T, angle, is 50. So measure of arc, minor arc, R to T, and that's how you write it, okay? Then if we went from T to R through Q, the long way, the major arc, we would say that's whatever the whole 360 is minus this 50 degrees. 360 minus whatever this minor arc is, and that's 310. This 50 plus this 310 makes the whole 360. Okay, so you can subtract this from 360 to find out what that major arc is. Remember, you have to label it with the point that it goes through the long way, T to Q to R. Okay, so that's what it says over here. The measure of major arc is the measure of the related minor arc, in this case 50, subtracted from 360. So 360 minus that 50 gives us the 310. Okay, and the measure, of course, of a semicircle is 180. You should already have intuited that. Now, adjacent arcs are arcs of the same circle that have exactly one point in common, like B to A and B to C. Those are two minor arcs that are adjacent to each other. Okay, and if they're adjacent, you can add the measures of adjacent arcs just as you can add the measures of adjacent angles. So you can say then that A to B to C is just the measure of A to B, minor arc A to B, plus the measure of minor arc B to C. Okay, that's the concept. It's kind of like the segment addition postulate or the angle addition postulate, the arc addition postulate. Cool. Let's apply it. Okay, so what we're doing now is we're finding the measures of arcs. Pretty straightforward, watch. So first of all, let's look at this. How can you find the measure of BD? Well, that's formed by adjacent arcs BC and CD, so you can add them together, right? and arc addition postulate. Now, what is the measure of each arc? BC. B to C, that's easy. B to C is, measure of arc B to C is equal to the measure of angle BOC, 32 degrees. What is the measure of angle B? I'm sorry, arc BD? Arc BD right here is the sum of these two smaller arcs that are adjacent. Okay, so arc BD is just the measure of arc BC plus the measure of arc CD, and 32 plus 58 is 90, so the measure of arc BD is 90. What is the measure of arc ABC? ABC going from here to here, that is half of a circle. That's a diameter here, so this is a semicircle, and a semicircle is always equal to 180 degrees. Yep. And then, of course, what's the measure of angle, of arc AB? And we know that this is 180. So we say whatever 180 is minus this is going to be what's left here from A to B. Okay. The measure of arc AB is equal to 180 minus this 32 section, or 148 degrees. Yeah? There you go. So here's your got it problem. You're going to write the measure of each of these arcs. And some of them we need to maybe calculate what they are because every angle is not given. Okay? So pause the video, write your answer down, then unpause it and check it against my answers. Pause your video now. Okay, so what is the measure of arc PR? Well, that's easy. The measure of arc PR is equal to 77 degrees. So you can just see it there. What is the measure of arc RS? Well, PRS, that's a semicircle, that's 180. If here's 77, then we've got the other 103 here. So it equals 103 degrees. And the measure of major arc PRQ, and we knew that this was 77, this was 103, that gave us our 180, and then we've got another 28 to get from P through R to Q. So 180 plus this is 208, and so the measure of arc PRQ is 208 degrees. Okay, finally, what is the measure of arc PQR? PQR going this way. Well, what we've got is the whole 360 minus this 77, yeah? P through Q to R, everything but this 77 degrees out of the total of 360. So if you took 77 away from 360, that would be 283 degrees. Yep, that's how you do it. Let's keep going. Okay, so this is something that you hopefully already know, but the circumference of a circle is the distance around the circle. And the ratio of the circumference of a circle to its diameter is pi. Okay? If you took the circumference and you said, I'm going to divide the circumference by the diameter measure, you get, because this is exactly pi times bigger than this, right? You could say that amount, when you divide it by this amount, is going to leave you a little more than 3.14, blah, 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 right? So the circumference, when you divide it by the diameter, you get pi as a value. Pretty neat, right? In fact, that's where pi comes from. So then that means that if you multiplied both sides by d to clear it off of the left-hand side, you'd get circumference is just pi times diameter. It's just another way of writing that. And that's what you see here. And another way of writing a diameter, because remember, a diameter is just 2 radii. Okay, we're going this way, and then it's opposite way that way. Okay, so you can write the diameter as just the diameter is equal to 2 times the radius. And here then, when you see diameter, oops, here then, when you see diameter, you can just write 2 times the radius, those two pieces. Okay, they put the 2 in the front and the radius in the back, but together 2 times r is what the diameter is, and so it gets replaced in the first, in the first formula by 2r. Okay, so the number pi is irrational. You can never write it perfectly unless you write the symbol. Okay, you can't write it as a terminating or a repeating decimal. To approximate it, you could use 22 over 7. You could use 3.14. But a better way to do it is use the key on your calculator, the pi key, because if you do that, you're going to get your answer much more accurate. Okay, let's do a little application here of this idea. So this is a little film crew, and they're doing one of these shots where they have the film dolly that circles around the person, and you can't see it. They don't shoot the ground, so it just appears as though you're just circling around a person, and you're seeing everything that the person on film is seeing around them. And where's the camera set and all of that? And that's what they're doing. They're riding around in a circle on a track. Kind of neat. Okay, so a 2-foot wide circular track. This is 2 feet wide here, right? From here to here is 8. Okay. For the camera dolly set up for a movie scene, the 2 rails of the track form concentric circles. Okay. The radius of the inner circle is 8 feet. Oh, that's from here to here. How much farther does the wheel turn on the outer rail travel than a wheel on the inner rail of the track in one turn? So we need to find what? Well, you need to find the distance around the track for each of these rails. So that's going to be the circumference of each of these circles, okay? Now, how do we do it? Well, what we need to do is we need to find the circumference of a circle that is 8 feet wide, and we need to find the circumference of a circle. What's 8 plus 2? Yep, so 10 feet wide. So we need to find the circumference of a circle whose radius is 10 feet wide. And then we'll subtract them because they want to know the difference. How much further does one go than the other? Well, we find out how far they both go and we subtract them. Let's take a look at what they show us here. Okay, circumference of the inner circle. Well, we know it's 2 pi r. That was part of our formula. And the radius is 8, so we say 2 times pi times 8. And that's 16 pi. If they say keep it in terms of pi, you'll often hear that, then you should keep it written like this. This is the only exact way to write that circumference, okay? Because once you substitute a number in for pi, it's not going to be exact anymore. Okay. Now the radius of the outer circle is the radius of the inner circle plus the width of the track, so that's 10, right? So we use that same formula. Circumference of the outer circle is 2 pi r, but now we're using 10 for the radius. This is 20 pi. Remember, when you subtract, the difference between the two distances is 20 pi minus 16 pi, or 4 pi feet. And if you type it into your calculator, you then find out that the wheel on the outer edge of the track travels about 13 feet if you rounded it to the nearest foot here. 13 feet farther than the wheel on the inner edge of the track, yeah? Okay, I know that you can do this. We're going to do this on the next page. You've got a got it problem. Okay, so the car has a circular turning radius of 16.1 feet. What that means is that that's how far the car is going to stick out from the circle that it's kind of carving out when it rotates around, right? That outer wheel is going to be 16.1 feet away. And we know that the distance between the two front tires is 4.7, okay? So then how much farther does the tire on the outside of the turn travel than the tire on the inside? And just as a hint, you're going to need to find out what the radius of this inner circle is, okay? And then we'll subtract again. Now, reasoning. Suppose the radius of circle A, is equal to the diameter of circle B. And we'll pick some numbers and talk about that in a second, but you need to make sense of it first. I'll let you give it a try. Okay, what's the ratio of the circumference of circle A to the circumference of circle B. And you can, I'm going to suggest if you want to solve this, that you make up some numbers and calculate them and see what you get when you set up the ratio. Okay, so pause your video now, solve these problems, and unpause it when you are done and have answers to compare to my answers. Okay, pause the video now. Okay, so let's see what's going on here. Car has a circular turning radius of 16.1. If we found out the circumference of that outer circle, we'd say the circumference is equal to 2 pi r. And what do we know the radius is? The radius is 16.1. And when you multiply that by 2, you get 32.2. So you get 32.2 pi feet, right? For the circumference, for that large one, okay? For the, by the way, this is A. And for that smaller one, we need to find out what is the diameter of that smaller one. So we need to do 16.1 minus 4.7. And that is, I'll write it in here, 11.4. So we then do the same, find the circumference, which is 2 times pi times r. And in this case, the radius is 11.4. So we get 2 times that, or 22.8 pi feet, because it's a measure of length, and so the units are feet. And when we subtract, we take 32.2 minus 22.8, and we get 9.4 pi feet. Okay, so 9.4 pi feet is approximately equal to, and I will take my calculator and I will type it in, see, and I get approximately 29.5 feet as the difference between the two of them. It doesn't tell me what to round it off to. It doesn't say to the nearest foot or anything like that, so I rounded it off to the nearest tenth, which is fine. Okay, now for B, it says suppose that the radius of A is equal to the diameter of B. Well, remember this, watch. We can say for the first one, what's the ratio of the circumference of A to B? Let's find the radius, or let's find the circumference of A. Circumference of circle A is equal to, they're saying that the radius of this one is equal to the diameter of the other one. So if we said 2 times pi times, let's give it a radius of, let's just say 10. Okay? That's the radius of this one. So then this one has 20 pi as its diameter, or as its circumference, right? And here for the circumference of circle B, we say 2 pi times the radius, and they say that the radius is equal to the diameter. I'm sorry, the radius of this one is equal to the diameter of this one, so the radius must be half. And we get 10 pi. And if we did the ratio of A to the ratio, to the ratio of circumference of A to circumference of B, what we would get when we wrote that like that would be 20 pi over 10 pi, which simplifies to 2 over 1. Okay? So if you double the radius or the diameter, you're going to get double the circumference. Okay? It's a direct linear relationship like that. Good to know. Let's keep going. There's a few more left. Okay. I shortened this up. There's some other stuff written, but we're going to skip it, and I'm just going to tell you, we're not skipping anything. It's just a longer explanation that you don't need to hear. Okay. The measure of an arc is in degrees, while the arc length is a fraction of the circumference. So what we would do is, let's say we have a circle here, okay? And here's the center. And we carve out this angle and we say, what is the measure of this if that angle is, let's say, 90 degrees? Okay, I know it's not a great drawing, but, and let's say we had a radius of 10, okay? So we say this is 10, let's say, meters, right? Then, since this is 90 degrees, what is 90 over 360, which is the whole circle? 90 over 360 simplifies down to 1 over 4, okay? So if we found out the circumference of the whole thing is 2 pi r, and we know that the radius in this case is 10. Well, we get a circumference of the whole thing of 20 pi meters, right? Because the units are meters. And I'm going to keep it in terms of pi. I'm just going to leave it like that. Now, if we are only talking about the blue portion, which is 90 degrees for a central angle, what amount of length is that? Well, 90 over 360 is 1/4 of the circle, so we want to take 1/4 of the circumference, so we're going to actually find that arc length. Let's call this, let's label them as, let's say there's an A and a B there. Then we could say minor arc AB is equal to 1/4 of 20 pi meters, or 5 pi meters. Does that make sense? Okay. Now, don't worry about this part. I actually want to cover that up and just ignore it. Okay. 5 pi meters. And here, what this says is, for example, an arc of 60 degrees is 60 over 360. That's a sixth of the circle. So the arc length is going to be a sixth of the circumference, just like I did a fourth of the circumference here. Okay. And this suggests the following theorem. Okay. Here it is. What it says is, the length of an arc of a circle is the product of the ratio, whatever the measure of that arc is, this angle right here, over 360, times the circumference of the circle, because you're taking that fraction of the circumference of the circle. So the length of arc AB is the measure of AB over 360. That arc over 360 gives you a fraction, and you multiply that by either 2 pi r or pi times diameter. Both of those give you the circumference, and you will find the fraction of the circumference you want. Yes. One more set of problems to do and we're done. Okay, so what is the length of each arc shown in red? Leave your answer in terms of pi. Well, we know that this is 90 degrees. We know that 90 over 360 is going to give you some fraction, and it's 1/4, times pi times diameter. They gave us the diameter, so we're using pi times diameter. Okay, and we say 1/4 of 16 pi is 4 pi, and the units are inches. 4 pi inches for that section. This right here, that's 240 degrees. Fun fact, 240 out of 360 is 2/3. Okay, so we're going to take 2/3 of whatever the circumference is, and the circumference is based on the radius. The radius here is 15, so they say 2 pi times 15, or 30 pi, and we want 2/3 of 30 pi, so we get 20 pi, and the units are centimeters. Got it? Okay. So what's the length of a semicircle? Semicircle with a radius of 1.3 meters. Leave your answer in terms of pi. You're going to pause your video and calculate this, and then unpause it when you have your answer. Pause your video now. Okay. So what we want to do to calculate this is we say that the semicircle will be equal to 180. Oops. Sorry, 180 out of 360, which by the way is equal to 1/2, times 2 pi r. I'm using 2 pi r instead of pi times diameter because they gave us the radius. And of course, we know what the radius is, so I'm going to plug that in here, times 1.3. Okay? So we're essentially saying 1/2 of 2 times pi times 1.3. And 1/2 of 2 right here is 1. So that just 1/2 of 2 is 1. That cancels out. Pi times 1.3. And so we have 1.3 pi. And the units were meters as the length of the semicircle. And that's it. Okay, that's the lesson. Try doing all the practice that you can in order to lock this in. You'll have some formulas provided for you on the quiz and test, but that's the basics of this idea. And we're going to apply this idea later in the next lesson to finding areas. When we know what the full area of a circle is and we say we can tell what some portion of the area because we know that this angle is some portion of 360. Yep, so we're doing now finding the circumference. Next time we'll be doing it to area. Okay, good luck.